Okay, good morning. Welcome to
Family Math number 42.
Family Math number 42. Today we're going to do a really cool exercise about satellite orbits that we were talking about the other day. But first we're going to do a fun thing with Nerf darts, and we're going to see how far a Nerf dart falls down when you fire it. Can you see the Nerf dart we have already on the wall?
Yep.
Yeah, point to it where it is, just in case it shows up on the camera. Okay, great. Now come over here. We're gonna put our little aimer right at that Nerf dart that's on the wall, and we're going to fire another Nerf dart. 3, 2, 1. Okay, now let's measure how far that fell. Gotta go quick. Is it about a foot?
It's about a little, it's like 1 inch less than a foot.
Okay, so it's about 11 inches. Okay, awesome. That is great. Are you you ready for our actual thing we're going to talk about now?
Yep.
Okay, here we go. Okay, here we are in the whiteboard room, and we're now going to talk about circular orbits. But first, our Nerf gun dart fell about 1 foot, right?
Yep.
And it took about 1/4 of a second. And how far away from the wall were we standing when we fired that Nerf gun?
About 15 feet.
15 feet. So we have to remember those numbers. It fell about 1 foot, going 15 feet in 1/4 of a second. Okay?
Yeah.
All right, so let's remember that. But for a circular orbit, what we need to do is we need to fire something so fast that it goes screaming out in this direction, and as it's falling down, the Earth is falling away from it just as fast. Right? That's what a satellite does. Right? Satellites are always falling. Right?
Yeah.
But since the Earth is curved, the Earth is falling away also. So the satellite just keeps falling all the way around. So what do you think that would feel like?
Wow.
Would you if you were up in the space station, would you just go, "I'm falling"? That's what it feels like. It feels like there's no gravity. So you're just what would you do? You would just kind of float around, right?
Yeah.
You're always falling. But now here's the neat thing about the math here. What we do is we say, what we're going to do as an approximation, we're going to say, let's see how far something would have to go in 1 second for the Earth to fall away from it as far as an object falls in 1 second. And if you go out and you drop an object and you look for 1 second, boom, 1/1000. Do you know how far something falls in 1 second?
16 feet.
About 16 feet, yeah. Did you know that?
Yeah.
Yeah? Okay. So something falls about 16 feet in 1 second. So what we're going to say is, we're going to fire an object straight out. We need it to fall 16 feet in 1 second. And so we're going to set up this really crazy triangle from the center of the Earth that goes out the radius. It goes over some unknown amount x. And the distance it has to go is r plus 16 because we want it to fall this 16 feet. Okay?
Yep.
So this is a nice little right triangle. And we have a great rule that helps us understand right triangles. You know what it's called?
Pythagorean Theorem.
The Pythagorean Theorem. And the Pythagorean Theorem tells us for a right triangle with sides A, B, and C, it tells us that a squared plus b squared equals c squared. Is that pretty cool?
Yeah.
Yeah? Do you know who invented the Pythagorean Theorem?
Pythagoras.
Probably. You sure it wasn't some guy named Steve? Probably not. Okay, so here we go. So x squared plus the radius of the Earth squared equals the radius of the Earth plus 16 feet squared. So we have to remember we need the radius of the Earth in feet. Okay? Remember we had our 1 foot ruler?
Yeah.
Okay, we're going to have to dig a hole to the center of the Earth and then use our 1 foot ruler to measure it. Can you go do that?
No.
No?
I don't think so. It would take a long time.
Okay, it would take a long time. So maybe we'll just look it up. Okay, so that tells us x squared plus r squared. We expand r plus 16 squared and we get r squared plus 32r plus 16 squared. Now, we have r squared on both sides of the equation. How can we get rid of that?
We subtract
We subtract r squared away, and I get x squared, which is what I'm looking for, equals 32 times the radius of the Earth in feet, plus 16 squared. You know what 16 squared is?
No.
Think about it. Keep thinking about it. See if you can figure it out. Okay? So, are you thinking about it?
Yeah.
Okay, good. Tell me when you know. 32, the radius of the Earth is 3,959 miles. And do you know how many feet are in a mile?
No.
No?
I've got it.
Hold on 1 second. Do you remember how many feet are in a mile?
No.
Is it 10? Or is it more than 10?
I think it might might be more than 10.
More than 10. It's more than 10. It's 5,280. So here's the radius of the Earth in feet. 3959 miles times 5,280 feet, and 16 squared is?
256.
Very good. How'd you figure that out?
Multiplied it out.
Oh, you did? You multiplied it out? Okay. It's also a power of 2, right?
Yeah, it's 2 to the 8th.
It's 2 to the 8th. Okay, now, this turns out, we're going to skip all this arithmetic here. It turns out that x is 25,863 feet, or about 4.89 miles. That's how far you have to go in 1 second. You have to go 4.89 miles, or about 5 miles in 1 second, which is about 17,384 miles per hour. That's fast, right? Now we have to figure out for a second if our dart was going that fast, so that we can see if that wall wasn't there in our house, would that dart have gone all the way around the Earth? Do you think it would have?
I don't think so.
You don't think so? All right, well, let's see. It went 15 feet in a quarter of a second. So in 1 second, how far is it going to go?
It went 15 feet in 1 second.
It went 15 feet in a quarter of a second.
Yeah.
So how far is it going to go in 1 second?
60 feet.
60 feet. Do you see how we figured that out?
Yeah.
15 times
15 times 4.
4. 15 times 4 is 60. Okay, so our dart was going to go 60 feet in 1 second. How far did we need it to go? How many feet do we need it to go in 1 second for it to be going fast enough to go all the way around the Earth?
We needed it to go about 5 miles.
We needed to go, right, 25,863 feet. But how far was it going to go?
It was only going to go 60.
Shoot. Okay, so now, all right, here's what we need to do now for our project this afternoon. We have to make a Nerf dart gun that's going to fire a dart that goes so fast it goes 25,000 feet in 1 second. Think we could do that?
Maybe.
That'd be one powerful dart gun, wouldn't it?
Yeah.
Yeah, it'd probably be a Guinness Book of World Records Nerf dart gun.
Yeah.
You think it would stick to the wall, or do you think it would blow the wall into shreds?
Probably blow the wall to smithereens.
Yeah. You think the house would fall down?
Maybe.
But it still would be really cool, right?
Yeah.
Yeah. What do you think Mommy would think if we blew up the house? Even though it was really cool. She'd be happy?
No.
No. Okay. Well, maybe we shouldn't do it then. But okay, so we just learned that 17,384 miles an hour is what it takes to go all the way around the Earth in a circular orbit at ground level. So satellites are a little bit higher, so you have to do a slightly different calculation. But that's cool, right? 17,000 miles an hour. Do you know how fast airplanes go?
About 500 miles.
They go about 500 miles an hour, so they're not even going fast enough.
No.
So our dart gun won't work, our car won't work, airplanes won't work. Maybe what?
Rockets?
Maybe rockets. Maybe we need a rocket.
Yeah.
Yeah. Okay. Well, maybe we'll do a little research today and figure out what we need to fire that dart gun. Okay.
Yep.
All right. Good job today, guys.